Hi, I'm Sonny Rivera, Senior Analytics Evangelist with Thoughtspot and Data Superhero for Snowflake. Today, we'll be talking to you about building ML models on Snowflake with Python and stored procedures. And I'm joined today with my partner in code, Chris Hastie.
Hey everybody, I'm Chris Hastie, a data architect working for InterWorks and also a data superhero. I'm really excited to walk through a few of the things I've learned today.
A little bit more about me. I'm a senior analytics evangelist, and I've been in the data space for over 20 years now. And I'm one of the early Snowflake data superheroes. Really excited to be here. If you'd like to follow me or reach out and connect with me, you can hit me up on LinkedIn or follow me on Twitter.
I've not been working in the data space for quite as long as Sonny. I've only been working in the space for about 8-9 years now, but I have been working with Snowflake for about 5 of those, working for InterWorks for just over 5 years, and working with data for pretty much my whole career. In addition to being a data superhero, I'm also a SnowPro subject matter expert, which means that I get the enjoyment of helping write a lot of the SnowPro exams that I'm sure some of you are familiar with. If you do want to reach out to me for anything, just hit me up on LinkedIn with the QR code below. And if you're interested in reading some of my blog posts, most notably my new series that's all about Python and Snowflake, then there's a QR code for you there too.
Okay, so let's talk about our use case a little bit here. We've got a business that's interested in forecasting their future sales, but they've moved to the cloud. So they can't run these models anymore on their local laptops. And oh, by the way, the data is so large, they can't use their local laptops anyway. Our analysts are used to using DataFrames. So they're familiar with pandas. They're familiar with Python DataFrames. So they need a tool that kind of lets them leverage their existing skills and lets them focus on self-service. And then lastly, since they build their models with Python, they want to self-serve, but they want to get out of those crazy dependencies and environment issues that they have with multiple different machines, multiple different environments, and having the ability to share that code. So that's kind of our core use case. And then we'll step through how we can enable those users with Snowflake, Snowpark, and Python. So Chris is going to take us through this next part.
So the objective that we're aiming to do in this session is give a brief overview of data frames in Snowflake and Snowpark and how they act as objects, before moving on to a few more specific information about the store procedures themselves. 2 store procedures we're going to be covering. The first will be some feature engineering and purely transformative, and we'll actually push all of the compute directly up to Snowflake. And the second will be one that will convert that data frame into pandas and do a few things with pandas and machine learning to create and model our data. Once we've done that, we'll then leave the Snowflake part and dive into a pretty nice looking Thoughtspot demo. The way that the Snowpark DataFrame API works is it can directly translate what you enter in a kind of Python friendly way. It can translate that into SQL code and execute that on Snowflake. So if you are more of a fan of using data frames and methods and that whole approach, then you can write your code like that. As you see in the example here, you can do a dataframe.filter, and the dataframe state is a value, and the query translator will reprocess that into a Snowflake query when it's pushed down to Snowflake itself to execute. To support this, Snowflake have partnered with ANACONDA, and this has been a really beneficial partnership from the perspective of a developer. Through ANACONDA's designated Snowflake channel, you can ensure that when you're developing your code locally, your environment can have the same packages and the same versions as Snowflake itself will use. Therefore, when you finish your local development and you push all of your code up into Snowflake in the form of a store procedure or a UDF or whatever, you can know and trust that you won't have any versioning issues or packaging issues because your environment should be matching already.
So let's talk just a minute about time series forecasting. And what we're using is a model called ARIMA. So what this stands for is the AR stands for autoregressive. That means it's a linear regression model. The I stands for integrated, meaning we do some differencing between the current values and the prior values. This is to help make the model what's called stationary. And then the last part is moving averages, the MA. That's really about moving averages for prior errors so we can reduce the errors in our model. But ARIMA is a very common and popular time series forecasting model. I will note also that I just learned Facebook's forecasting model called Profit is now on the Snowflake Python channel with ANACONDA. So you could use that model as well.
Before we're able to do all of our fun data science, machine learning part of this, we want to look into actually transforming and preparing our data. In order to do that, we're just going to do a few pieces of data transformation. This is all something that I've built in a local environment using some Jupyter notebooks in VS Code. And if you want to follow along or be able to do any of this yourself, the Git repo will be available at the end of this deck, and you can grab that. So what we're aiming to do here is filter the data, aggregate it, sort it, and eventually store those results in a new table. Effectively just clean it, create some features, get it arranged. A key part of this is we are only using Snowflake data frames. And it's an interesting point here. We have two types of data frames, Snowflake data frames and Pandas data frames. A Pandas data frame is actually containing the data. The data will have been downloaded into a specific Pandas object, and then you can do all of the things that you're familiar with doing. A Snowflake data frame, on the other hand, is more like a representation of a connection to a Snowflake object. So as you can see here, we create a data frame for our source, and that is actually just simply referencing a table in Snowflake. And you can see if we do a show on that, we can see what the data looks like. Before we can actually do specific transformations in a very standard Python way, we need to import the packages, the functions that we wish to use. As you can see on this slide, we have a full set of functions already provided and supported by Snowflake within the Snowpark for Python package. And these functions will align with their SQL equivalents if you were to run them within Snowflake themselves. So what we want to do here, first we want to filter our data, and we want to filter it for all of the values for 2005 onwards. We achieve this filter very similarly to how we would normally for pandas. There is a slight difference though. You can see we use a col function. All this is really doing is isolating the specific column that we wish to use. As I mentioned before, the Snowflake data frame is a representation of a connection. So we use this col function to actually reference a specific column. Now that we've filtered our data, we want to take the next step, which is aggregating the sales by the month and category. You can see we can leverage some of our useful Python tricks, like putting things onto different lines and just chaining different methods. And we leverage this to chain a group by statement, an aggregation statement, and finally a select statement that replaces the aliases for different columns. After grouping it, just to make things nice and easy for ourselves, we are going to sort the table again by the sale month and category. By performing this sort, we can just make sure that everything is in line and together so that when we apply our auto-ARIMA model, everything is already in line and structured how we need. Finally, we can write the information from our data frame back into a Snowflake table. And to be honest, I think this is the most interesting and most useful part of this so far. So by using this write.mode method and then outputting using save as table, we can take a data frame as we've been working with in Python and see that result output up into Snowflake. The really cool part of this is that until this point, none of the data had actually moved anywhere because we've been using Snowflake data frames and we've never downloaded it into a Pandas data frame. Everything has actually effectively been a representation of code or a sequence of SQL statements. So when we execute this final part to save our information as a table, this is where the Snowpark compiler will convert everything we've got so far for our data frame into one great big long SQL statement, and then execute that SQL statement to yield our final result.
Okay, so let's talk about modeling our data and creating an ML model. So we mentioned earlier we were going to use AutoArima. So we need a few packages, right? We need a pandas package. Chris has been talking about that. We need the AutoArima package. And then, of course, we'll still need the Snowpark package. But really straightforward things we're going to do here. We'll import those packages and start rolling from there. So let's get started here with referencing all of the data that Chris did the feature engineering on. So he used those Snowpark data frames to do the feature engineering, and we're just going to reference that exact same table. Now, in this time, we're going to take that data and add it to our machine learning model. So you can see we really just have sales by category and for each month. Now, to use this in our machine learning model, we need to do a little bit of conversion work. As Chris mentioned, Snowflake data frames are a little bit different than pandas. So we're going to convert that over, and a little statement like this saying, okay, take this Snowflake data frame and let's create us a new pandas data frame. And you can see the data that we have again, month of sales, the category of the sales, and the actual sales amount. So now that we've converted it over to pandas, it is important to note that there are some slight differences. Pandas handles date times a little bit differently than maybe Snowflake does. So we'll do a little bit of a conversion there. This is a quick little snippet, but you may have some other conversions that you need to do. But date times are ones that jump out at you early. So make note of that. All right, for our model, to make this a little simpler, we're going to just filter down by category. So you can see that we're taking our pandas data frame and we're only going to use the enterprise product that's been sold. And that's just a simple filter here. So let's create the predictive model. Now, the first thing we need to do to create the predictive model is we need to separate our data out into what we are going to train with and then what we are going to test with. So we're going to pull the last 2 years out and use that as a test set, and everything before that we're going to use as our training set. Okay, so what's really cool about the AutoArima model is it's really a model that will hyper-tune itself, right? So there are several parameters that we pass into the model. You know, you heard me talking earlier about the regression part of the model, the integration part of the model, and the moving average part. Well, each of those has a parameter. And as a data scientist, to do this work can be repetitive. Set parameters, run the test, see what's working. Oh, let's try it again. Oh, let's try it again. Oh, let's try it again. So we do this over and over, and it can take a long time. Well, with the AutoArima model, we can kind of set parameters and say, I want you to run a bunch of models and figure out which one is the best one to use. And that's what AutoArima is doing here. On the left side of the screen, you can see that AutoArima is running through all of these models and looking for the model with the lowest value for AIC. In data science, you know, we're often looking to get the least error or the smallest amount of error. AIC is a single factor that kind of balances the model complexity with the amount of error. And we're going to let AutoArima pick our best model for us. And what's really nice about this is all of this code is running in Snowflake's environment once we push it to a stored procedure, it'll run in Snowflake's environment and leverage its clusters. Right here, it's running in my local environment. So on the right-hand side, you can see a summary of what we've done, and it's picked, you know, the AIC with 1965, and that it feels is the best performing model. So let's see what it looks like. Well, before we can see what it looks like, we need to actually run some predictions. So we're going to use some predictions on the same data that we train. This is called in-samples. So we'll run some in-sample predictions, and we'll store those off. So you can see those at the bottom of the screen here. So we'll also do the same thing for our test data, right? So we're going to take that same test data and we're going to run predictions on that as well. So effectively the same thing, only this is data that we didn't train on. So these will be true predictions, if you will. We'll combine the test and train predictions with the original sales value. So we can see how well, or we can actually see the error associated with this is what the actual sales were. This is what I predicted it to be. How far off is it? One great thing we'll do before we start looking at that is let's do what Chris reminded us to do and write our results back to Snowflake. So with this a little pandas method, write pandas, we can actually write the data frame in pandas to a table within Snowflake. Now here I'm creating just a little bit of code here for visualizing what this would look like in a Jupyter notebook. This is just a map plot, some code to do that. And so you can see here, we have what's in orange is the predicted values out of our training. What's in blue is the actual values that we trained on. And then we can see the error at the bottom, right? So those errors are in the low percentages, 1%, 2%. I think the highest might be about 4% error in that space. So we're also going to compare our predictions from our holdout test set. Remember, that was the last 2 years that we didn't actually train the data on. Very similar set of code for creating that map plot and comparing the values of our test set and the error that we had with the actual values. Okay, so what you can see here is the blue values, or the blue line, is what we trained with. The orange values are our test data, the actual values, and then the green line is our predicted values. So that actually looked pretty good. So Chris is going to kind of take us through what it takes to turn that code I wrote into a stored procedure for ML modeling. So Chris?
Absolutely. Thanks, Sonny. So there's a lot going on this slide. Don't worry if you can't fully read it. As I said, the code's all available on GitLab. What we're really doing here is putting all of the code that Sonny just ran through into a single function in Python. So that's this whole left-hand side. We are creating a function called generate auto-rumor predictions. We pass it an origin table, so the table where our data comes from. We pass it a destination table to write the data to at the end. And very importantly, we also pass it what is known as a Snowflake Snowpark session. And this is the connection that Snowpark is using to do all of this Python stuff and interact with Snowflake. By creating this function, we can then use a separate sproc register method, or store procedure register method, to convert that function into a store procedure. And when we do that, you can see on the right-hand side here, we've got a few things that we can enter, things like the name of the function, the stage that we're going to be uploading the code to, because it does need to go somewhere. This is an upload at the end of the day. And just a few bits of information on the input types and the return data type. One other thing we've done here, just to build up on what Sonny had before, is instead of just targeting a single category, we have within this store procedure built in a loop that will go through all of the distinct categories in our input set. And then after running all those models, it will then glue the outputs of each of those together again into one final table. If we then decide that we want to execute this within Snowflake itself, you can see here we have a screenshot from the Snowsite UI within Snowflake. First, I execute that line at the top where I call my generate auto-rumor function, and I pass to it the input table, product sales, and the output table, product sales predictions. Once I've called that, I can run this simple select star statement, and I can put it into a chart using Snowsite, and I can straight away see where my test prediction values are overlapping against the actual sales figures. And we can see again, like Sonny mentioned before, that these predictions are doing quite well. They're pretty close to what we would be expecting.
So let's go through a quick Thoughtspot demo to show how you might visualize and how your end users might use this. So let's take a look at the sales forecast live board in Thoughtspot. As you can see, this is similar to what we showed earlier within our code that was running in our Jupyter notebook. These are in-sample tests. And with Thoughtspot, we've written all of our results back to Snowflake, and we're rendering them for our end users to take a look at. So we can see our error, we can see the values that we trained. These are our training predictions versus the actual sales that we saw. The same goes true for that holdout set, those test validations that we did. Again, we see the error in red at the bottom. Usually you have a little bit higher error on your actual holdout sets than you do on the in samples, and we can see that some error as high as 8%. But our predictions look pretty good, right? So we've got in yellow our predictions there, and in blue our actual sales. So again, our model's looking pretty good. As you can see, this is just a rolling average trend. We have a rolling average, and we can see that our sales are going up. But which would you rather have? That, or would you rather have a prediction that actually shows you, hey, this is what our data is going to look like very, very closely to what it actually looks like? So this is really validating our model. What I'd really like to show you is how this is used by our business users. So let me switch over to that screen and show that to you. So let's take a look at how our business users actually use this information. So here's a quick dashboard in Thoughtspot that our business users have. And basically this is showing our sales daily. So each day it's reporting our sales. But our business users want to see not just what happened in the last 30 days, but what's going to happen in the next 60. So within Thoughtspot, just come in and say, hey, next 15 days, let's say. And now it's using that same predictive model that we built earlier to say, what does sales look like next week and the week after? And then what's really cool is we'll do a little bit of analysis. I'll click these 2 points and I'll say, hey, let's use our AI spot analysis to analyze what's driving this change from low to high. So we'll do that. And as you can see, within a few seconds, we'll get back, hey, here are the key factors that are contributing to that upward drive between, October 5th and October 9th. And so we can see all the different categories. Is it product? That's, which products are driving this? Which regions, which states, who's overperforming, who's underperforming? And as you can see, hey, maybe the South and the West are predicted to underperform. The East is going to be on market, and the Midwest is going to be surpassing their goals. So this is how our users use Thoughtspot today and use this ARIMA model to evaluate current sales and future sales.
So this wraps up the main content really for our session. We've been through Snowflake and ANACONDA, how they're working together to simplify the developer's life. We have touched on the Snowpark DataFrames API and Snowpark for Python and how we can use that to either use Snowflake DataFrames or how we can use Python DataFrames and what some of the pros and cons are for each side. And then we've got onto the real meat of our topic, which is building processes to manipulate data using Snowpark and building stored procedures to create and apply a machine learning model. All of this, because it is then a stored procedure, can be executed by a typical Snowflake user by just calling the stored procedure. And this allows your developers to do things in a way that they feel comfortable. If they are Python people, then they can use all of the Snowpark that we've shown today. And you'll notice that we didn't actually execute any SQL code today until that very final part where we created that stored procedure and then demonstrated simple SQL to execute it in Snowflake. But if your users want to, they can just stick within Python. They can just use Snowpark, and that can be their playground. If they are a SQL person who prefers SQL, then that's fine too. And they've got all that functionality to execute these models or to leverage everything that we're doing here. And they could do it all in a SQL way. So yeah, that wraps up our side of the demo. I'm going to hand over to Sonny for some final links and some shares. But thank you very much for listening. Again, I'm Chris Hastie, and I'm really grateful that you stuck around for this talk.
Thanks again for joining us in our talk today about Snowpark, Python stored procedures, and building machine learning models on Snowflake. All the code is here on this screen with the GitHub repository. Just hit these QR codes and you can go directly to the code. We also have a quick starter for Snowflake and Thoughtspot. That's on the screen as well. And of course, there's links to how to get in touch with and link with Chris and myself. If you liked this video, if you got something out of it, please give it a like and subscribe to Snowflake's YouTube channel. Thanks again.
Hello, we've got a breaking news alert. Now bear with me as we don't quite understand what's going on as of yet. Our Channel 8 News team is being bombarded by reports of what people are calling data superheroes. Here's what we know so far. Multiple individuals have been spotted all over the globe doing what can only be described as saving our data. We have this clip submitted to us by Felipe Hava, and it seems to show a figure flying in and doing something incredible to the old industrial mill on 53rd Avenue. That is simply amazing. Now joining us live on the scene is Elsa Mayer. Elsa, give us an idea of what's going on over there.
Thanks, Leigh. I'm here downtown where moments ago, 2 individuals were spotted lifting, rising up alongside this building here. This is truly unbelievable. If it weren't for the footage captured by Daniel Myers, I wouldn't believe it myself. Leigh, back to you.
Thanks, Elsa. Stay safe out there. Here now is some footage coming out of Amsterdam of what seems to be a person holding back a tsunami of data. I'm not sure what's even going on here. Adding to all of this, cities around the world are starting to see this symbol pop up. What does it mean? Who are these people? It looks like these data superheroes are somehow saving our data. I'm not sure what's going on, but I can tell you this. I'm sure glad they're on our side. For Channel 8 News, this is Leigh Tarauschis signing off.